Alright, hello class. In this video we're going to be talking about linear transformations, basically transforming a function. So there's this word linear that we use in mathematics to essentially refer to things where if you do something to one thing, the exact same thing happens to everything else. So one common example of something linear that most people are familiar with is something called a guitar capo. So if you don't know what that means, you probably at least know someone that plays the guitar, and you've probably seen them with that little clippy thing. So basically, if you put that onto one of the frets of a guitar, that makes everything go up a certain number of steps. Literally everything. So that's an example of linear. So essentially, each of these will do something to every single point. And there are two ways to transform. So there's scaling. In other words, you multiply things by certain factors. And there's translation. Translation is transformations where you use addition or subtraction to make them happen. So these things A, B, H, and K that you see here, so this is something called graphing form. These are called parameters. They will do certain things to certain variables. So let's just get into what they do. First thing is scaling versus translation. A and B, they scale because, as you can see over here, A and B are multiplying to things, right? A is multiplying outside to the y values, and B is multiplying inside to the x values. And H and K, they're adding and subtracting, so they're going to be the ones for translation. So how do these actually affect f of x? First thing is you need to have reference points. What a reference point is essentially just points that once you know them and you have them plotted, you can easily plot the rest of the graph. For instance, for sine, if you know where the top and the bottom and then the roots are, it's really easy to graph, right? So I'm just going to quickly draw it like this. So here, max, min, and then the roots. So it's really easy to just draw that once you have the points, those reference points. So you always want those, and the easiest thing to do is just transform the reference points. So here's what the parameters actually do. So, should have drawn a line there. Oh well, I'll draw one now. So A, B, H, and K. A tells us that we're going to be doing a vertical scaling. Vertical just means y value stuff, as you can see from the fact that it is multiplied outside of the graph, so or the function up here. So that's going to apply to the y values. B, going to apply to the x values, same type of thing. Scaling by a factor of A. So, actually, I'll just write the graphing form thing down here. But yeah, so what's going to happen then is all the y values for A get multiplied by A, and for B, all the x values get divided by B. For H and K, you're actually going to add H over B to all the x values. So it's a little bit weird, but essentially what's happening is you see inside here, certain things are happening. And so you're already transforming the x values with B, so that means H has to be transformed relative to the B values. And it does that essentially through division. And you might be wondering why you have to divide by B. Essentially because you're multiplying all the values by B, all the x values, the graph is going to essentially compensate by dividing all its x values by B so that everything will scale correctly. You can just do a few examples for yourself to see how that works and why it works. I just don't want to do that here because it's going to take a lot of time. All right, so K. This is actually, I would say, the easiest one to deal with. You're just adding K to all the y values. So let's just work with this. And yeah, so the K thing actually is pretty self-explanatory. You're just adding K to everything at the end. So all y values, add K. Alright, so let's practice reference points for this. This is a parabola. How you can tell is by this thing, the squared. So negative 1/2 times negative x plus 1 squared. So parent graph, and then minus 1. So let's look at the reference points for a parabola. Easiest ones to deal with are just going to be here, 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 and here. So you want those 5 points, which are going to be the origin, negative 1, 1, and 1, 1, and then the 2's. Negative 2, 4, and positive 2, 4. So what transformations are happening here? So there we have a vertical scaling by negative 1/2. And then we have a horizontal scaling by negative 2. And a horizontal shift 1 over negative 2. So, well, technically the h here is negative 1. Because remember, we have minus h. Since this is plus, h had to be negative. So, negative 1 over negative 2 units. In other words, that's going to move to the right. And vertical shift 1 unit down. Alright, so scaled points. Let's just get some points written there, and then we'll graph this thing. So what's going to happen when we scale it? So all of the y values are going to be multiplied by negative 1/2. So let's just do that real fast. So 0 times negative 1/2 is still 0. Then negative 1/2, negative 1/2, and then negative 2, negative 2. How about the y values? We're going to divide by negative 2. So still got 0 for the x values. And then we have 1/2. And we have negative 1/2. And then, let's see, that's going to give us a 1 and a negative 1. Alright, so then we're going to translate the points as well. So, actually, wait, I think that's supposed to be to the left. Yeah. So anyway, what's going to happen here is, because of the fact that we had a negative 2, that's actually going to affect things and make things go kind of opposite to what this normally would tell us. Normally this would tell us that we're going to go to the right, to the left. Oh no, yeah, that is the right. Sorry. So it's going to move to the right because it's going to negate that essentially. That's what the whole division thing is. So, which points are we going to use here? We're actually going to use the points right over here and work with that. Okay, so we're going to multiply, shift 1/2, so that means add 1 over 2 to all the x values, because it's going to the right. So that's going to be a 1/2, that's going to be a 1, that's going to be a 0, and then a 3 over 2, and then a negative 1/2. And then what happens to the y values? 1 unit down, so subtract 1 from all of them. And then we will end up with these points. And then we can just start graphing the translated points. So the stuff that we got at the very end. I'm just going to draw the axis real quick. So we know that 1/2 comma -1, that's going to be like our origin point, so to speak. So we don't need huge points here necessarily, so I'm just going to divide this into, I think I could divide this into 3. Yeah. 1, 2, 3. 1, 2, 3. 1, 2, 3, and then 1, 2, 3 again. Okay, so let's just plot those points and get our parabola. So, got 1/2 comma -1. We have 1 comma -3/2. I probably shouldn't have done it in thirds, but oh well. 0 comma -1/3. And then 3/2, so 1.5 comma -3, so that'll be around here, and then yeah. So we got those points, and then all we need to do then is connect them. That is our graph. Alright, so not too difficult. Really easy once you think about the whole dividing or multiplying or adding and whatever to those points. Get the reference points, do that. Alright, so if you think you're good with this, you can definitely stop the video. I'm just going to go into one more example of this. It has to do with asymptotes and stuff, so if you want to look at that, sure. Okay, so just going to go over this pretty quickly. So parent function is tangent, pretty clear there. So what is important in tangent? Well, -π/4 comma -1 is important. So is 0, 0, and π/2 comma 1. And then two things. Vertical asymptotes at x equals -π/2 and x equals π/2. So transformations that are happening here, we have a vertical scaling by 2. We have a horizontal scaling by 1/2. And then we have a horizontal shift by 1/1/2, so by 2 to the right. And then we have, a vertical shift down 3 units. So let's get those reference points, and in this case also asymptotes. So for the scaled points, we notice that we have a few things going on. The x values are going to be multiplied by 2. So we got -π/2, 0, π/2, and then all the x values, including the asymptotes, then are going to be affected. So we got x equals -π, and then x equals pi. Alright, so how about the y values? Scaling by 1/2. So this is going to have us divide by half, so multiply by 2. So we got -2, 0, 2. Alright, we got the scaled stuff. Now let's get the translated stuff. Horizontal shift by 2 to the right. So that means all the x's, add 2. Alright, so 2 would just be 2π/1. Wait. Let's see, 2/2. So 4/2. So, oh, that'll be interesting. Okay, so let's do that. It's going to be a little bit weird, but oh well, we'll make it work. So, let's see. Actually, let's make that a pi. So 2π to the right. That'll make things a lot easier, so because we're dealing with pi's, right? So we got 2π to the right. Alright, so using this, if we go 2π to the right, that'll get us at 3π/2. That's going to get us to 2π, and that'll get us to 5π/2. Vertical asymptotes, x is going to be, let's see, that's going to move over by, okay, so that'll just be at pi, and then that'll be at 3π. All right, how about the y values? Everything shifts down 3, -5, -3, -1. All right, so now let's graph this. I just noticed that I forgot to actually get the graph. So I'm going to copy and paste that from up here. Good thing it is on a different layer. I think that's on the layer. Yeah. Okay, so we don't have many negative x values, so we don't really need to worry about the negatives. Let's just go to super positives. So something like that. And how about the y values? They're mostly negative, so let's make it something like this. So 1, 2, 3, 4, 5, 6, 7. So -1 to -7, x values, y values. And then let's see, we need to get up to 3 pi, so let's just do 1, 2, that's pi. And another 2, that's 2 pi. And then another 2, that's 3 pi. I'm just going to stop that there for time reasons. So we know that we have one asymptote there, we have one asymptote there, and we have point at negative 3 pi over 2, so that's over here, and then comma -5, -1, 2, 3, 4, 5, 2 pi comma -3, so that'll be a -3 right there, and then 5 pi over 2 comma -1 right there. Then we can just connect that together, and then we have something that looks like that. Alright, so here's just some examples how this looks. Hopefully this helps, and see you in the next video.